All right, we're going to do integer multiplication with our integer chips. 3 times -4 is the first one we're going to do, but times isn't very meaningful. Can one of you tell me what 3 times -4 means? 3 groups of -4. Okay, so 3 groups of. Okay, so 3 groups of -4. All right, so what should I, like, so we're having groups of -4. So we're having 3 groups of this, right? Okay, so 3 groups of -4. So we have 1 group of -4. Let's do 2 groups of -4. Okay, and then 3. Am I still on the screen? Yes. 3, up, up, up. 3 groups of -4. That wasn't all that horrible. So we've got 3 groups of -4, and I kind of made an array. Well, I did make an array, and we showed 3 groups of -4, which I don't, whatever. Okay, so 3 groups of -4 gives us -12, and we drew a picture of it there. If we were drawing this rather than using the chips, we would go 3 groups of -4, -4, 1 group, -4, 2 groups, -4, 3 groups. And we get a -12. And I'm stopping because I don't like this problem, and we're done. Okay. All right, we're going to do integer multiplication. This is 2 times -4, but times doesn't have as much meaning, so let's make this more meaningful. Can one of you tell me what 2 times -4 means? Okay, so 2 groups of, because it's repeated addition and we're just adding -4 twice. So 2 groups of -4. Okay, so here's a -4. There's 1 group of -4, and next we have another group of -4. So straight away we see that we get a what? What do we see? We see a -8. Awesome. So if you wanted to just draw that, this is pretty straightforward. You would just draw the 2 groups of -4. 1, 2, 3, 4. There's 1 group of -4. There's the second group of -4, and you get -8. And you're done. So an integer multiplication, when you're doing a positive number of groups of a negative number, is really quite straightforward. Now this problem's pretty much the same, except that it's really not the same according to Common Core. So this says -4 times 2, but how would we say this with the whole groups thing? What would we say here? Take away 4 groups of 2. -4 groups of 2 means take away 4 groups of 2. I'm going to write that down. So in the last problem, we were putting in groups of something, and now we're taking out groups of something. So let's look at that. Take away 4 groups of 2. Well, there's nothing here, so how do we take something away from nothing? What do you think we need to do? Oh, okay. So if we put in some 0 pairs, there's a 0 pair. But can we take away 4 groups of 2 yet? No. So we need more 0 pairs. Let's put some more in here. Just like, I don't know. Let's see. This is a lot of 0 pairs. Here we go. So can we take away 4 groups of 2 yet? Oop, I gotta zoom out. Can we take away 4 groups of 2 yet? We can? 4 groups of 2? Almost? Maybe? No, we can't. Okay, so we saw 4 groups of 2 of different colors, but we need to take away 4 groups of 2. So here's a group of 2, and here's a group of 2, but we only have 2 groups of positive 2 we can take away. So we need to keep introducing 0 pairs, yeah? Okay, so I'm going to rearrange this a little bit because this is getting kind of messy. Okay, so we need more 0 pairs, darn it. Okay, so putting in more 0 pairs. How many groups of 2 do we have now? Do we have 4 groups of 2? How many groups of positive 2 do we have now? 3 groups of positive 2. Okay, so I'm going to kind of break these out this way. Here's a group of positive 2, here's a group of positive 2, here's a group of positive 2. So we still need some more integer pairs, or 0 pairs, whatever you want to call them. Okay, there's another one. Here's another one. Whew, what a pain. Can we now take away 4 groups of 4 groups of 2? Okay, so here's a group of 2, 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. Oh, very painful. So we're taking away 4 groups of 2, take away 1 group of 2, take away 2 groups of 2, take away 3 groups of 2, take away 4 groups of 2, and we now have left on our page this -8. But that was really painful, yeah? Yeah, that was horrible. Okay, I'm going to draw it this way, and this is how Common Core wants you to do things. When you have a multiplication problem and you've got a negative in the front of it, this is how they want you to do it. So I'm going to go ahead and draw what happens. We start here with nothing on the table. So let me zoom in so that that stuff's not on the table. And then because we need to take away something from nothing, we need to put a bunch of stuff here. So I'm going to put a bunch of stuff here. Hopefully this will work nicely and neatly. I'm going to put in a bunch of integer pairs. Okay, so I now have 2 groups of 2. We're going to do exactly what we did with the chips. So, okay, so now I just did what they asked us to do as far as like what the Common Core wants us to do, and then I'm going to show you how I would do this because I think this is kind of silly. Okay, so we're trying to take away 4 groups of 2. So we're taking away 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. Take away 4 groups of 2. Okay, so there we took away 4 groups of 2, which means that now we're left with, let's see if I can zoom out and not have too many chips all over the table. Cover them up, they're not there. So now we're left with 1, 2, 3, 4, 5, 6, 7, 8 negatives. And after we take away 4 groups of 2, we're left with -8 because we had to take it away from a 0. But I don't think that that's a logical way to do this problem at all. I know that Common Core says we have to do it that way, and technically for this problem we do have to take away 4 groups of 2, but I think that given this problem where they're not both negative, I don't think like there's any reason to make a mess. There's a property that can make us rewrite this problem. What's the name of the property we can do to make us write this so that we don't have a negative in the front there? Commutative. So -4 times 2, we know we have the commutative property, which means that we can write this -4 times 2 as 2 times -4, because we know the commutative property works. We know it doesn't matter which way we multiply and we'll get the same thing. And with this problem, it now says 2 groups of -4. Well, damn, that's a lot easier. I probably shouldn't say damn when I'm being recording, but whatever. So 2 groups of -4. So now we're putting in 2 groups of -4. 1, 2, 3, 4. We put in 1 group of -4. 1, 2, 3, 4. Come over here, little guy. 1, 2, 3, 4. In this case, we just put in 2 groups of -4. So, and there we have our -8. So I'm going to draw how you could draw this. And a lot of people do it this way. So we're putting in 2 groups of -4. I'm going to make it a little more visual than the last time I did. So here we are. We're putting in 2 groups of -4. So my little arrows are like, look, we put them there. There was nothing, and then we made this stuff show up. And then we end up with our -8. Okay, so I feel like you should be savvy and use the commutative property. Use commutative property and do it this way, because this was a hot mess right here, like blah. Okay, so there is a case where we do need to do that, and that's when we have two negatives. So let's do one now that has two negatives and see what happens. Let's just do should we have the smaller number in the front or the back to try to be nice to Common Core? So what do you think? Smaller number? Okay, go ahead. Sorry. Okay, so we're going to do -2 times -4. This time it's two negative numbers. So we are saying take away two groups of -4, which is really annoying. And so far we have nothing. So we sure as heck can't take away two groups of -4. So we're going to have to introduce a whole bunch of zero pairs in order to do this. So zero pairs, zero pairs. We're going to add a whole bunch of, or introduce a whole bunch of zero pairs. Okay, so we now fast forwarded and introduced two groups of -4, and we're supposed to take away, because of the negative, two groups of -4. Can we now take away two groups of -4 now that we put all these darn zero pairs in there? Yeah, okay. So here's a group of -4, and here's a group of -4. And right now we have 0 there. So we can take away two groups of -4. One group of -4, gone. Another group of -4, gone. It's like you didn't exist. And we end up with what? 8, just a positive 8. So now I'm going to draw that with my handy dandy double pen thing going on here. So first we have nothing, and it's asking us to take away two groups of -4, but we don't have anything there, so we can't take anything away. So we got to put some stuff there. I'm going to try to be all, fancy schmancy with my dry erase markers. So here's a zero pair. We still have nothing there. Zero pair, zero pair, zero pair, zero pair, zero pair, zero pair, zero pair. Okay, so I had to make sure that there were two groups of -4 to take away before I could take them away. So now we have two groups of -4, so I need to take them away. I think I was using green for take away last time because it went somewhere. Maybe that's what it was. And it's harder for me to do it when it's this way, but whatever. So we're going to take away one group of -4, and then we're going to take away a second group of -4. And then what we're left with, and this time I'll just go ahead and draw a little arrow over here. We're left with, next step in our progression of stuff, is we're left with boop, 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 boop. So we're left with a positive 8. Okay, so there's our final answer, and here's our work. We had nothing, we had to introduce zero pairs, and then take away two groups of -4. So just as long as you're thinking about multiplication as groups of something, and if it's negative groups of something, you either have to use commutative property to make it not be take away and messy, or you have to actually take away whatever it is. And sometimes you need to put in zero pairs to make that possible. So I hope that helped with multiplication of integers.